Today we're going to look at a particular kind of trig problem. It's got a very important idea in it. So instead of jumping right in the problem, I'm going to set it up and then we'll do a couple examples real quickly. So I drew a right triangle in each of the four quadrants. Notice that theta is always connected to the origin there. I'm not using this angle out in space. Also, notice that the right angle is always attached to the x-axis. So whenever we're doing these problems and you're drawing these like we did in the last assignment where there was a dot and you connected it, the theta should have always been attached to the origin, like one of these, and the right angle should have been on the x-axis. All right, so I want you to think about, for each of these, sine, cosine, tangent, cosecant, secant, and cotangent. And before we even start, let me remind you that sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. All right, so for each of these triangles, let's name the sides: opposite, hypotenuse, and adjacent. So in this one, this is the hypotenuse, 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 hypotenuse. The opposite side is opposite from theta, so this would be opposite here, 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 and here. And just by process of elimination, this must be the adjacent. Now in geometry, you usually said all the sides of a triangle are considered positive distances, and that's true when it's floating in space. But when it's attached to a coordinate axis, that will not always be true. If I have one of the angles centered at the origin, then I can talk about the legs being so many units on the positive side of the origin or on the negative side, or on the positive side of the origin or the negative side. So one thing you have to know, where can I write this? The hypotenuse is always positive. That is a very important statement. The hypotenuse is always positive. So I'm going to write a plus by all of the hypotenuses. All right, now let's look at the opposite sides. See how the opposite side goes up? That would be positive. The opposite side goes up, that's positive. The opposite side is below the axis, that's negative. The opposite side is below, that's negative. Now let's think about adjacent sides. Adjacent side is on the positive x-axis. The adjacent side is on the negative part of the x-axis, the negative part and the positive part, right? From 0 we're looking. So, notice that sine is opposite over hypotenuse. Plus over plus equals plus. Cosine is adjacent. Look, everything's positive. So adjacent over hypotenuse, opposite over adjacent. That's going to be positive. That's going to be positive. And all the reciprocals are going to be positive. So I could say everything So I could say, if the triangle is in quadrant 1, remember this is Q1, and then you go this way. This is Q2, this is Q3, and this is Q4. Every trig function is positive in quadrant 1 because of the reasons I just laid out. All right, let's look at the next one, quadrant 2. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. Cosecant is the reciprocal of this. Secant is the reciprocal of this. And cotangent is the reciprocal of this. So for this one, notice that only sine and its reciprocal is positive in Q2. What about Q3? Sine is opposite over hypotenuse. That's negative. Cosine is adjacent over hypotenuse. That's negative. Tangent is opposite over adjacent. A minus over a minus is a plus. Okay, then I have the reciprocal of this, the reciprocal of this, and the reciprocal of this. Oops, keep wanting to put ones. So in quadrant 3, I see the tangent and its reciprocal. And lastly, we have quadrant 4. So sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, reciprocal of this, reciprocal of this, reciprocal of this. So in quadrant 4, cosine and its reciprocal all right, so we're going to take these results. This is like showing you why it's true. The important thing is this bottom line, and I'm going to take everything you see on this board and condense it in one nice, easy to remember package. So, pause it if you wanna, because I'm going to erase. All right, all that information you can remember by remembering this, where stuff is positive. So this is what I advise you to remember. The way to understand this is like this. Sine, tangent, and cosine, and their recips are positive in Q1. See, this is quadrant 1. What's positive there? Sine, tangent, cosine, and you just got to remember their reciprocals too. What are their reciprocals? Cosecant, cosecant, cotangent, and secant, right? What is this saying? Only sine and its reciprocal are positive in Q2. Only tangent and its reciprocal in Q3. Only cosine and its reciprocal in Q4. Right? And then, so you remember this chart. Remember that's positive there. just the hidden part is, remember, so is its reciprocal, because reciprocals have the same SIGN. Well, what does it mean if I don't see a letter? Do you see a T here? No. Then tangent is not positive. I guess that means tangent is negative here. Sine would be negative here because I don't see a S. Tangent would be negative here because I don't see a T. And so would its reciprocal. Cotangent would also be negative, right? So this chart tells you everything you need to know, and I'm going to rewrite that smaller, and then we're going to do some problems to see how this works. Okay, you got that? So in your head, and that's why I write STC, because you go around the horn in this direction. So this is S, then T, then C. All right, so I'm just going to grab your book and do some even problems out of the set that I'm going to assign you. So ID the quadrant. Cosine theta greater than 0. Cosecant theta greater than 0. Cosine theta less than 0. Sine theta less than 0. Cotangent theta less than 0. Secant theta less than 0. Sine theta greater than 0. Tangent theta greater than 0. So here's a bunch of different problems. They want you to identify the quadrant, and they tell you this. And you go, I don't know. So let's be logical. Remember, don't just throw up your hands and surrender. Identify the quadrant. What does your answer look like? It'll be Q1, Q2, Q3, Q4. If you didn't know that, see, just go one step at a time. Now, this is a basic idea. It always amazes me how long it takes people for this to not have to be reminded of this. What does this mean? And do not tell me cosine theta is greater than 0. I didn't ask what it says. I asked what it means. What does greater than 0 mean? It means positive. That's another way of saying positive. When you read this kind of math junk, these go together. When you read this kind of math junk, ain't nobody going to tell you that that's what it means. You're supposed to know, pre-calc student, or whoever's watching this. Cosecant is less than or greater than 0. So first of all, I don't like those reciprocal ones. We want to go to the primaries. So this is the same as saying sine is greater than 0, because reciprocals and the originals have the same SIGN. So sine is positive. This is outright telling you cosine is positive, and this is implying that sine is positive, because if its reciprocal is positive, so is the original. Now think about it. Where in this picture is both the sine and the cosine positive? Well, it's wherever you see both letters. Sine yes, cosine no. Cosine yes, sine no. This is the only quadrant that both S and C are positive. So that must be quadrant 1. That is the only place where at the same time cosine and sine are positive. Cosine is negative. Sine is negative. Well, where are they both negative? Wherever I don't see an S and a C. Only in the third quadrant is the sine not positive, and also the cosine is not positive. Right? If I picked quadrant 2, that would be false. If I picked quadrant 4, this would be false. If I picked quadrant 3, both of those are true. That's got to be the answer. How about this one? Well, that's the same as saying the reciprocal is less than 0. So that's saying tangent is negative. And this is like saying cosine is less than 0. So that's saying cosine is negative. So what I'm looking for is where in the picture do I not see the T and the C? That would be quadrant 2. Where is the sine positive and the tangent positive? What quadrant will you see both an S and a T? They're both positive. Only quadrant 1. Right? So you're going to do some problems like this. All right, I know that I'm pushing my limit on the time here, but there's one different kind of problem we got to do. It's much different than these. And I'm going to run through an example so you can do some. So I'm just picking an even problem right out of your book. Find the other 5 trig functions given, and then there will be a bunch of different problems under these instructions. So here's an example. Cosine theta is minus 3/5. Given that theta is in quadrant 3. Okay. How do you do these problems? 1, draw the triangle. So you see those words? You've got to draw it. Here's a coordinate system. See how it tells you the theta is in quadrant 3? That would be this variety of the problem. Right? That's the quadrant 3 triangle. Now what is this telling me? Remember that cosine is adjacent over hypotenuse. So that's got to be the hypotenuse, and that's got to be the adjacent. That minus is a problem, so think about that. Remember I told you the hypotenuse is always positive? So the hypotenuse is 5, and that minus must go with the 3. And look, that makes sense because that's back. That makes sense. 2, find the third side using the Pythagorean theorem. And hopefully I didn't need to tell you that. You just looked at it and realized it was true. So let's just call that x for the moment. Minus 3 squared plus x squared equals 5 squared. I don't even need to compute it. This is the classic 3, 4, 5 right triangle. It makes no difference if the negatives because they're squared. So I know that this is going to be 4. You can crank it out if you want. 3, give your answers. So what is the question? All right, so see how it told me that cosine, so I got to find sine, tangent, cosecant will be easy because it's the reciprocal of this. Cotangent will be easy because it'll be just the reciprocal of that. And secant is like a freebie because secant is the reciprocal of the given, right? I didn't even got to think about that one. But the other two, I got to look at my picture. See why we have to draw it? Because now it will make sense. So the sine is opposite. Oh, my bad. Look where that 4 is. See how it's down here? That better be minus 4. All right, now we're good to go. Sine is opposite over hypotenuse. So I'm going to knock out its reciprocal at the same time. Tangent is opposite over adjacent. And those minuses are going to cancel. Right? A minus over a minus is a plus. And this will be the reciprocal. All right, so there's a couple more problems. I'll just warn you, see how this is given? A couple of problems do something like this. Instead of saying this, they'll say this. So this is exactly the same, but now they told me tangent theta is greater than 0. Well, what does that mean? That means tangent is positive. And where is tangent positive? In quadrant 3. See, so in some of the problems, instead of them telling you it's quadrant 3, you're supposed to figure it out. And then you do the problem exactly the same. All right, so those are these are probably the toughest problems you'll do in this part of the unit. So give it a try. Let me know if you have questions.